Okay, the first one here, it says that AB is parallel to CD. And it says that BC is parallel to AE. So you have parallel lines and transversals. There. Okay, what next? It also says that angle ABD, so when you identify the angle, follow the dot ABD, so it's talking about this angle right here is 3x plus 4. Then it says that BCD, so this angle right here is 6x minus 8. And next, let me grab another color. It says that EDF, this angle right here is 7x minus 20. Now you have to figure out which ones are equal or supplementary, so that way you can figure out what x is. What it's actually asking for is a measure of BCD, so this green one here. This is what we're actually going to be solving for when we get there, so we can keep that in mind. Okay, so like what do we have here? It might take you a while to kind of figure this out, but just to kind of shortcut, this angle right here is the same measure as this one because they are corresponding. And this angle right here is the same as this one because, again, they're corresponding. So now what we have is these three angles here are supplementary and they add up to 180. So we're going to literally put these equal to 180 and then solve for x. Now I could write it out horizontally, but I already have it stacked here. So 4 plus negative 8 plus negative 20 is negative 24. And 3x plus 6x plus 7x is 16x. And then I can solve for x. Okay, we get x equals 12.75. Then, remember we're solving for measure of BCD, which was the green, so we'll plug that in. 6 times 12.75 minus 8 will give us the measure of angle BCD. So measure angle BCD equals 68.5. And that's what you would type into the box, 68.5. Okay, so this will be worth credit. Of course, the whole packet will be worth a lot of points. Make sure that you have all the work down. Okay. The next one's actually a bit easier. I'll move it down. This one, it says match each building with the geometric shapes that can be used to model it. So in the first one, we see cones here, cone here, and here. So it has a cone. On FSA, you would just like click that box. Remember, a cone looks like this. A cylinder looks like this. A pyramid would have like a square or a triangle on the bottom and look kind of like this. And then a rectangular prism would be like a tissue box. Like that. Tissue box. Okay, what else does it have here? It looks like the bottom of this shape is a cylinder, so it also has a cylinder. So you check those two boxes. On the computer screen, it's actually a little bit easier to see because these are in color and you can see the shapes a little bit clearer. For this one, we have a cylinder right here, cylinders. So we definitely have cylinders, and the actual building is a rectangular prism. So we also have a rectangular prism. And number 2, again, it's kind of hard to see because it's not in color, but on the screen it's easier to see which shapes are here. There's actually a pyramid right here, and again, when you have the color, it'll show it more like a pyramid. So we have a pyramid right there. Again, Again, it's hard to see, but there's actually a cone right here. I know, it's hard to see because of the colors, but there's a cone right there. And then there is a cylinder right here. I know you wouldn't have seen it unless I pointed it out. It's okay. And then the rectangular prism is right here, yes. Yep, it's everything. Okay, number 3. Number 3, it says in the diagram shown, chords A, B intersect C, D, so it's saying that these intersect. We can see that in the picture. What's nice is they did give us a picture. The information they're telling us is also right here. They're telling us that arc measure DB is 2x and arc measure AC is 120. They showed us in the picture. And then the angle AEC is 4x degrees. One of the theorems states that the average of this arc and this arc equals this angle. So to solve for x, we would do 120 plus 2x. So these two arc measures added up, divide that by 2 to find the average, equals 4x. Now we're going to solve for x. So when you're dividing by 2 like this, you can actually split this up. 120 over 2 plus 2x over 2 equals 4x. Just solving for x at this point. 60 equals 3x. So that means x equals 20. Okay, now I need to look at what they're actually looking for. I found x, which is important, but it says what is the measure of angle AED? Be careful here, because AED, when you connect those dots, it's actually this angle that we need to measure for. So we're going to find this angle, which would be 4 times 20. 4 times 20 is 80. Or wait, not 80. Yeah, it is. What am I doing? Okay, 80 degrees. And then that's supplementary to the angle we actually need. So we can do 180 minus 80 equals 100 degrees. So the measure of angle AED is 100 degrees.
Wait, why'd you do 180 minus 80?
Because it wanted me to solve for this angle. So 80 degrees was this one, and it's supplementary to that. Oh, yes, I did take a picture. For some of these, I did include this here because that's what you'll see on FSA. You'll actually have to press on those buttons. The degree actually wouldn't go there. I shouldn't have drawn that, but it'd just be 100. You can press on the buttons or type it. It's up to you. Next one, it says Kyle defines a circle as a set of all points equidistant from a given point. Explain why Kyle's definition is not precise enough. Well, when you have a middle point and all the points equidistant from that point, what he doesn't specify is that it's in a 2D plane. So all the points equidistant from that point would actually make a sphere instead of a circle. So what he needs to write in the box, and there's different things you could write, of course, it's open answer. Their example for an answer is because his definition is true for a sphere. For a circle, you'd have to specify that all the points equidistant from a given point in a plane. So he should specify that the set of points is in a plane. Or on a plane. So both of these answers were given as examples. Notice that they aren't complicated. Like this one wasn't even a full sentence because his definition is true for a sphere. That's why it's not precise enough. Okay, next question. This one, it says triangle SRT is shown. It says choose the correct equation or phrase to fill in the blank in the paragraph. For each blank, fill in the bubble before the equation or phrase that is correct. It says the vertices of this triangle, which they already graphed for us, which is nice, a reflection across a line, and we have to choose a line, and then across another line, is the same as a translation of 4 units to the right and 4 units up because the lines are blank. Here's where we need to start with it. It wants to know which reflections are the same as a translation of 4 units to the right and 4 units up. So I'm actually going to translate this shape. It says 4 units to the right, 4 units up. So for each point, 1, 2, 3, 4, 1, 2, 3, 4. And remember, on a computer screen, you're not going to be able to draw it out. You might have to draw it out on your scratch paper. 1, 2, 3, 4, 1, 2, 3. T prime is right here, and R prime. Here's our new shape. What I'd recommend for this is guess and check. It wants this reflected twice over 2 lines, and it gives you the lines here. So I'm going to draw the line first, x equals 4. That would be right here. And I'm doing it in pencil because I'm going to erase. But if I was to reflect it over that line, it wouldn't land on that. And then reflecting it again, it's not going to land there. So I know that's not correct. Then x equals 6. If I were to reflect this original over that line, and then reflect it again, it's still not going to land there. The next one, y equals negative x5. To graph this line, the y-intercept is 5. And then our slope, negative 1, 1. Negative. So here's the line. That might be correct. You could take your time going through these answers, but the 4th one is actually the correct one for this first blank. So I'm going to graph this line. 6, down 1 over 1, and you'll see why it works in a second. Okay, there's this one. So this would be D. And then the next one, again, you'd have to guess and check through this, but the answer is actually C. And graphing this line, okay, so if I was to reflect this over here, it would look like this. And then if I was to reflect it again, it would land right here. And so those are our 2 answers here, and then because the lines are parallel. Okay, and the next one. Number 5, Johnny wants to find the equation of a circle. It has a center as 3, negative 4, and a radius of 7. He uses the argument shown. Choose the correct word or phrase to fill in each blank in the argument. For each blank, fill in the bubble before the word or phrase that is correct. Okay, well, just writing down the equation of a circle. The equation of a circle is x minus h squared plus y minus k squared equals r squared. This is the horizontal and the vertical. It tells us that the center is at 3, negative 4, so plugging that in, it would look like this. X minus 3 squared plus y plus 4 squared equals 7 squared, which would be 49. Okay, now what? Here it wants to know the horizontal distance from x, y. Well, here it is, x minus 3, so that's A. And then vertical distance is the y plus 4, so the answer is D. Then the total distance from xy to the center of the radius, 7. The blank can now be used to create an equation that shows the relationship between horizontal, vertical, and total distance of xy to the center of the circle. Out of these, perimeter formula would be length plus width plus, it doesn't really make sense for the situation. Pythagorean theorem, a squared plus b squared equals c squared. If you look closely at the equation of a circle, it is a squared plus b squared equals c squared. So that is our actual answer. And then quadratic formula is that, you may remember from algebra, negative b plus or minus square root of b squared minus 4ac. There's nothing similar to that there. How are we doing on time? 16 minutes? Should we stop at 20? How are you guys doing? We should stop at like 20 minutes? Okay. Okay, a proof with some missing statements and reasons is shown. It shows that this is a parallelogram. It says also in the given that PQ is congruent to QR. So this is the same length as QR. In the proof, it has a bunch of blanks. However, what's interesting about the proofs on FSA is it doesn't ask you to fill in all the blanks. It usually only asks you for like 1 or 2. Hold on, Hannah. Drag the correct statement from the statements column and the correct reason from the reasons column to complete line 3. So all it's asking for is line 3. Okay, given, we could drag that in easily, but they aren't asking for that. The given is that it's a parallelogram. They also tell us that these two are congruent. We need to prove that it's a rhombus. A rhombus is a parallelogram, but with all sides equal. A parallelogram has opposite sides equal, so therefore if we know these two are equal, then we also know that the opposite sides of that are equal, and it does make a rhombus. That's what they're looking for 3. We need to say that PQ is equal to SR, because in a parallelogram, opposite sides are equal. So PQ equals SR, and PS equals QR. That's our reason for 3. And the reason is opposite sides of a parallelogram are congruent. And that's your answer that you would like drag and drop there on the computer. Oh, it doesn't matter. I was just showing that it's not similar to the equation of a circle at all. It's like negative b plus or minus square root of b squared minus 4ac, and that goes over 2a if you want to be technical. That's the quadratic formula. Okay, let's go over to the back. What time does class over? Class isn't over for 20 minutes. I know you guys are getting tired though too. But the more we get done today, the less we have to do later. Okay, a regular pentagon, EFGHI, with center K is shown. Select all the transformations that carry the pentagon onto itself. For this, it is a select all question. With the select alls on FSA, let me get it to focus. Select all means that there's 2 or 3 correct answers. So keep that in mind. Anytime it's a select all for FSA, that is, it's 2 or 3 correct answers. Okay, so it wants to know which transformation has it mapped right onto itself. The only way to do this is to go through each answer choice and kind of sketch it out to see. So starting with the first one, a reflection across line EK. If we were to reflect this shape across EK, it would land onto itself. And then a 180-degree counterclockwise rotation about point K. That would put it like facing the opposite direction. And if you're not writing, make sure you're writing in pencil if you're sketching this out. And a reflection across the vertical line would again put it back onto itself. So this is a correct answer. Again, if you need more time to really think about this, you might want to do this on your own as well. The next one, focus. A 90 degrees counterclockwise rotation about point E, so that would put that over here. And then a reflection across line EG or FG would put it like over here somewhere. And then a vertical translation would put it up here. That does not map it onto itself, so this is not a correct answer. Next one, a reflection across line FI. Is that the, oh, I'm looking at FI would be right here. If we were to reflect it over that line, we'd have something over here. And a reflection across the line GH, that would put it over here. And a 180 degrees clockwise rotation about point K would put it here. It's not onto itself, so not an answer. The next two, a reflection across the vertical line through point K, vertical line being right here. A 180 degrees rotation would put it back onto itself, and then a reflection across this line would put it onto itself as well. This is a correct answer. And the last one, a 180 degrees clockwise rotation about point E would put this shape over here. A reflection across a vertical line through point E would put it back onto itself. And then a reflection across a horizontal line through E would put it onto itself as well. It would reflect onto itself. So that is correct. I wish there was an easier way to do it, but that's it. Okay, how many more? What are we at? 22? Let's go to 25 minutes. Let's keep going. I know, you guys can do it. Okay. Next one, you saw something like this on Geometry Nation. It shows Alejandro cut a circle with circumference C and radius R into 8 congruent sectors and used them to make the figure shown. Here it is. Alejandro noticed that the figure was very close to the shape of a parallelogram. Okay. Select all the statements that apply to the figure. So again, we're looking for 2 to 3 correct answers because it's a select all, 2 to 3 correct answers. So we'll look at each one. The height of the parallelogram is approximately equal to the circle's diameter. No, the height would be approximately equal maybe to the radius of the circle, so that is not correct. The area of the parallelogram is approximately 1/2 the circumference times the radius. Well, actually so the area of this would be like length times base times height. Half of the circumference would be half right here, and the height would be the radius, so that is actually true. Next, the length of the parallelogram is approximately equal to the circle's circumference. No, the length here would be half the circumference. That's not correct. The radius of the circle is approximately equal to the height of the parallelogram. Yeah, that's true. And the area of the parallelogram is approximately this. Well, what is it saying here? If I was to take 360 and divide it by the 8 sectors, I would get 45 degrees for each sector. 45 over 360 would be like the fraction of the circle for each one, times by the area of the entire circle. So that would be the area of just one sector. And then I can multiply by 8 to get the area of the entire thing. So that is correct. Okay, do you want to stop there? Good for today? Okay, good job, y'all.